In this video, we'll see how shifting operators are used in C++ programming language. First of all, we should note that shifting operators apply only to integers. There are two shift operators available in C++ language. One is this left shift operator, which is made up of two symbols, less than symbol twice, and the other one is the right shift operator. By making use of left shift operator, we shift the bit pattern corresponding to an integer towards left hand side, and accordingly, similarly, right shift operator is used to shift the bit pattern of an integer towards the right hand side. Okay. Now recall, in case of Turbo C++, int, that is the integer data type, was of 16 bits. And all modern Linux operating systems, they are of 64 bits. So size of int is typically 64 bits. Here, for example, I have assumed that the size of an int is 2 bytes, that is 16 bits. And if it is an integer, by applying left shift operator, here it is the variable to which this left shift operator is being applied, and this one represents the number of bit positions the bit pattern is to be shifted towards left. Here we assume that when we are shifting towards left, there is an infinite supply of zeros from right hand side. Okay. Similarly, when we shift towards right, we assume that there is an infinite supply of zeros from the left hand side. Okay. Now, suppose, for example, here x equal to 5. So you can see here this bit is 1, this bit is 1. So the value is 5. If we shift it towards left hand side, bit position becomes, bit pattern becomes this one, which is given here. So this one has come here, and this one has come here, and a 0 enters in the least significant bit place. So this value becomes 10. So if you shift a bit pattern towards left hand side by 1, the number gets doubled or multiplied by 2. On similar lines, if the bit pattern is shifted towards right by 1, the bit pattern shifts towards right by 1. So this one goes out. Okay. So 0 comes here, and this one has come here, and there is a 0 which enters here. So this is 2. So actually it is integer division. If you divide an integer by 2, for example 5 here, 5 divided by 2 has to be 2.5, but in this case it will be integer part, and the result will be 2. Now pay attention here. If you shift a bit pattern towards left hand side 15 times or 15 bit positions, and suppose the value of x is 1, then what will happen? This 1 would come here, and assuming the size of an integer to be of 2 bytes, this number is being treated as a negative number, because in most of the computers in sign magnitude form, if most significant bit becomes 1, the number is treated as negative, and all negative numbers in modern computers, most of the computers, if not all, they are represented using 2's complement form, and this is the representation of minus 32,768. If we declare the variable to be of type unsigned int, then the things may be different. So this should be the result, but across platforms, across various implementations, the results are different, and you cannot be definite. You cannot be sure what is going to be the value. So if you want to get the certain values, if you want to be certain of the output, then make sure that while shifting towards left hand side, do not shift by those many bit positions which result in most significant bit becoming 1. Okay. Now I have written a program. Let me show you that program. On the right hand side, I have shown this program. Here, remember, I have put this 5 towards shift left 1 inside parenthesis because this value is to be evaluated. This value is to be evaluated. If I remove this parenthesis, then what would happen? It will simply print 5 followed by 1, which would appear on the screen like 51. Okay. So here it was not required, but here it is essential. So it's better to enclose the expression to be evaluated within parentheses. Okay. And here in this case, it would print 2. And here I am waiting for two numbers to be entered at the keyboard. One, the number which is to be shifted, and second, the amount of shift. Okay. And then it will shift by that amount this number towards left hand side first, and then towards the right hand side first. Second. Okay. Now let me execute the program. See here, 5 shifted towards left hand side. The result is 10. 5 multiplied by 2. Now in response to this, shifted towards right hand side, the number becomes 2. 5 divided by 2, integer division. Now here it is waiting for us. Here it is waiting for us to type in two values. So now suppose 5, the number 5 I would like to shift towards left and right, and maybe 2. If I press enter, now you can see here, it has been shifted towards left hand side by 2-bit positions. That means multiplied by 4. So 5 multiplied by 4 is 20, simple. And similarly, now here the result is 1, because this 5 shifted towards right hand side becomes 2, and this 2 shifted towards right hand side by 1-bit position is 1. So this is the way we can make use of shift left shift operator and right shift operator in C++ programming language. That is all in this video. Thanks for watching.